Fundamental to problem solving. Let's talk about that for a moment. GIS is composed of software, hardware, spatial data, procedures or methods, and most important of all, people. It is the person who turns spatial data into knowledge, spatial knowledge, and communicates that knowledge to others so that more informed decisions can be made. The GIS education community is concerned about spatial thinking because why? It is the spatially literate person who can make the most out of GIS analyses. One can build fine models with accurate spatial data, but without spatial thinking, the results won't be fully seen for what they are, and the information will not be transferred as effectively. GIS has always been a thinker's tool. Therefore, along with nurturing GIS skills, we must encourage spatial thinking as fundamental to all GIS analysis. We often must teach some basic concepts if we hope to have students grapple with advanced spatial problems. For example, I recently had university students locate a fire tower using a digital elevation model, DEM. For example, in this activity, I had them look at elevation, land cover, hydrology, and roads. Many of the students didn't grasp the problem because they didn't understand what a DEM was, or even how elevation was represented. We therefore had to spend some time working with topographic maps and isolines, what's a contour line, etc. It wasn't the students' fault. They were simply products of a primary and secondary education system where they were lucky to have a geography class maybe way back in grade 7. So they weren't knowledgeable and skilled in these concepts. We had to back up a little bit, but once we did, they were able to move forward. Take advantage of these moments, as I just described, to teach spatial concepts and skills, even in advanced courses. We should also encourage students to think holistically and spatially about problems with which they are wrestling with while using GIS software and skills. Sometimes students review available tools, then frame the problem accordingly. This could result in a narrow view of the problem. Encourage students to think about the whole problem first and then model how they will use GIS to help them address it. Encourage them also to think beyond the software. Think beyond the software, folks. I can't emphasize this enough. Think beyond the software. Spatial analysis preceded GIS, and some analytical methods are better combined with other tools. Use GIS as one of what could be several analytical tools and methods to make effective decisions. Use